Okay, so today we're going to apply something called the intermediate value theorem. You had an ed puzzle to watch on this prior to this video. If you have not done so, I would definitely recommend to go back and watching that. That explains kind of the theory behind what we're going to be solving today. The intermediate value theorem, basically in a nutshell, says that if a function is continuous and we know the endpoints, then we can say that a function is going to hit every single value in between those endpoints. So it looks something like this. We abbreviate it to IVT, intermediate value theorem. It basically says for the notation that we used in the ed puzzle video was L, for any L between f of A and f of B, there exists a number which referred to as C in the interval AB such that, or for which, f of C equals L. All right, that's a lot of math jargon. But again, like what I said, what this actually means is if we have two values, let's say in this graph that's given here, if I called this one, this -2, if I called this my A, this 3, I called that my B, the Y value is what we refer to as the f of value. So this Y value up here would be f of A, and the Y value of this one would be f of B. So again, just to remind you, f of A and f of B, that is a Y value. You could think of it as sort of like Y sub 1 and Y sub 2 if you want to. Because they're the function values, just like f of x is the same thing as y. Okay, so this function says, or this theorem says, that if we have some continuous interval between A and B, then there's got to be some value we'll call, our function goes like this or something like that. There's got to be some value which we'll call L, maybe it's right here, such that f of C equals L. So there's some C, that's an x value, and that f of C gives you L, meaning between those two, f of A and f of B, we're going to hit every single value at least once in between there, every single Y value. The problems here on DeltaMath are, they use this formula. The only difference is they use a K instead of the L. So no matter what calculus textbook you read or what website you read, they might use slightly different letters for that. The A and the B and the f of C are generally pretty consistent, but the L sometimes is not L, sometimes it's just referred to as f of C, or sometimes it's referred to as K, which isn't in this problem. All right, so let's see if we can apply this. So we're going to be asked to answer some questions here. First of all, to determine if this theorem can even be applied. So we're given some information. The very first thing that you always want to make sure you look for is that f of x is continuous on some domain. That is always check number one, because this has to be a continuous function on some domain, some interval that it gives us. If it's not continuous, then the IVT does not apply. So that's our very first check, if it's continuous. All right, and we have a plot of it here. I'm going to delete this stuff. Such the portion of the graph, the interval, -2, 3. So this is actually the interval we're going to be talking about here, -2, 3. So think of this as your A, and this is your B. So here our A, and this is our B. Given that f of -2 is 6, so that means this here, this is f of -2. The Y value there is 6. And f of 3, that's here, equals 4. Determine what conclusions can be drawn based on the intermediate value theorem on the interval -2 to 3. So again, this is the interval we're talking about, -2 to 3. That's our A and our B. Then we got our f of A and our f of B. All right, so we're going to go down here and see what we can do. First thing we have to determine is if the IVT actually applies. Since the function is, now I underline continuous, In all these problems, it will either just skip that or it will say continuous, or I guess it could say not continuous as well. But since this function is continuous on its domain, continuous, the intermediate value theorem can be applied. Right, we can apply it because it is continuous. And this theorem states that for any value k, all right, now this is where it just gets a bit confusing. K is the same thing as L in our actual theorem. So for any value k in the interval, now in this particular problem, what they're looking for is y value. Since they're talking about k, that's a y value. Think of this as the same thing as f of c. K, L, f of c. I know it's confusing, but those are all the same thing. So what we want to type in is the interval for the y values. Our y values that we had were 6 and 4. So those are going to go into our first interval. Now just make sure you put these in the right order. Even though the 6 comes first on the left side and 4 is second, you want to put them from biggest or smallest to biggest. So we're going to do 4 to 6. So basically this is saying that we're going to hit every number from 4 to 6 on this function, because there's no way to get from 6 down to 4 without crossing every single number in between. So we got to hit 5.9, we got to hit 5.8, we got to hit 5.7, 5.6. You can't just magically skip 5, right? You can't just jump from 5.1 to 4.9. You have to hit every single number in between 6 and 4. Right? If it's continuous, there's no way you could skip it. It's not a piecewise function. So then there exists a value c. Okay, so now the c is talking about x values, right? This is an x value. So we want to put the interval for our x's. That was -2 to 3. Such that f of c equals k. All right. So it's saying that between the interval -2 to 3, there's some y value between 4 and 6. There must be a value of c in the interval -2 to 3 where f of c equals 3. It's asking you that question. So could we say that this function definitely hits 3 in this interval? Does this hit 3? Well, it could, right? It could go from here and it could go down all the way down there and then back up. But the question is, must it hit 3? Does it have to get 3 in order to get there? Well, the answer to this is, well, no, because we can go from 6 down to 4 without ever crossing 3, because 3 isn't between 6 and 4, right? Now, if it had said 5, f of c equals 5, that would be a yes. But this is a no because 3 is down here, right? So we don't necessarily have to cross 3 in order to get to 4. From 6 to 4, you don't have to cross 3. You could, but we can't say for sure if it actually is the case. So we're going to say there may not exist, meaning we don't know. There could be, there could not be. We can't say based on this theorem a value in between those two. All right, and I know that was a lot happening there, so we'll do a couple more here. You do have 3 attempts on these. I would just make note of like whether you plug in x values, y values into these different intervals. I know it is a bit confusing, but it does help you learn the definition, learn this theorem pretty well, I think. Okay, first thing to look for when we start this, make sure the function is continuous on whatever interval we're talking about. This one does say it's continuous on the entire domain, -9 to +9. So that means it is continuous on the little interval we're going to be looking at there, which looks like 2 to 7. So since it is continuous, the intermediate value theorem does apply, can be applied. Okay, now states that for any value k, remember k is a y value. So basically we want to put the y intervals here. If it helps to go ahead and just label, this is your A, this is your B, right? This is your f of A, your f of B. The A value was 2 to 7, because the A is 2, B is 7. And then our y values, f of 2 is -5, so that's the y value, and then f of 7 is -2. I'm sorry, this should actually go here. -2, all right. So remember, this first one is looking for y values. So the y value is from -5 to -2. And that's what we're talking about. There exists a value which we're going to call c. Okay, c is an x value, somewhere in here maybe, right? Which is between 2 and 7. Those are the values is between 2 and 7. The open interval 2 to 7. Such that f of c equals some value k. Right. So this function is going to connect in some way, like that, right? We don't know exactly what it does. But let's see if we can answer this question. Must there exist a value of c in the interval 2 to 7 where f of c is -3? In other words, do we have to cross -3 in order to connect this function? The answer to this one, if we were to draw sort of a dotted line across -3, is absolutely yes. There's no way to get from -5 to -2 without crossing -3. We can't just skip that one. So since it is continuous, it's on this interval, we can say yes, definitely, you would have to cross -3 at some point, because there's no way this function can get from -5 to -2 without crossing the point -3. So there exists a value of c in the interval 2 to 7 such that f of c equals -3. Let's try a couple more here. Okay, the next one, the function has a domain of -99, it's plotted below. Now notice it does not say it is continuous in this one. It will always, I believe, say it right before that domain, where it'll say like continuous function or whatever. So this one does not say continuous, meaning we can't necessarily apply the intermediate value theorem. So since the function is not necessarily continuous, we can't say for sure that it isn't continuous. It just doesn't tell us if it is or not. So we're going to put not necessarily continuous. The intermediate value theorem cannot be applied because we have to know for sure it's continuous if we're going to apply it. All right, therefore, see what our options are here. There may or there may not exist. All right, we have no way of telling a value in the a value of c. All right, so it's talking about c in the interval. So we're talking about c's, that means x values, -4 to 3, where f of c equals 2. Now it looks like there would be. It looks like if we just connected this function right under normal circumstances, you would definitely cross f of c, some c value where it's 2, right? It looks like you would. There'd be some c value here. Here's our a, here's our b, such that there's an f of c, which is 2. However, it's not necessarily continuous. So for all we know, maybe there's a hole right there at 2. We can't say for sure. We don't know about this function. So since we can't say for sure, we can say there may not exist or there may exist. The wording, again, is a bit confusing, but we're going to say there may not exist. We can't say for sure that it does not exist. We just know that we can't tell for sure. So that's what we're going to go with. Once you get the pattern of these down, they're not too bad. This next one, notice again that it doesn't tell you anything about whether it's continuous or not. It just says it has a domain. So we're going to say not necessarily continuous, cannot be applied because we don't know if it's continuous. Therefore, there may not exist. And then the x there, which is -5 to 0. There might be some value where f of c equals 0. However, we can't tell because we don't know if this function is continuous. Again, maybe this is a piecewise function. Maybe it goes up for a bit and then drops off and then starts up again. We don't know. So there's nothing we can say for sure. Let's do one more with a continuous one. A lot of non-continuous here. All right, here we go. The function f of x is continuous, so that means we can apply it. It's good. So let me go ahead and put continuous. The intermediate value theorem can be applied. Okay, so now we've got this interval, -5 to 2. So this might be connected in some way like this, maybe. We don't know. But it is connected, and we know it is continuous. Given that f of -5 is -5, so again, this is an x value, this is a y, x, this is a y. So here's our a, our b, this is our f of a, f of b. The question is, remember the first interval, we always put, this is referring to k is a y value, so we're going to put our y values in first. The y values are -5 and -7. -5 and -7 are our y values. But make sure you put them in the correct order. I've made that mistake. Actually, I'm going to just make that mistake here just to show you here. So this should be -5 to -7 based on left to right, but we know it should be lowest number first, then the highest number. So again, this part's wrong, but I just want to show you that here this is wrong, but we'll just submit it, try to make them correct that mistake. All right, there exists a value c. This is where we put c as x value, so we're just going to put our a and our b from -5 to 2. Such that f of c equals k. Must there, so again, this is a question, must there exist a value between -5 to 2 such that f of c equals -4? In other words, well, the question you want to ask is this number in that interval? Is it in it? Well, not necessarily, right? Our function might go down to -4, but it might not. Our function could go, just say up, could go like that and then down. -4 would be right here, but we can't say for sure. All we know is that it's going to go from here to here, and it hits every number in between. So we know it's going to do -5.1, -5.2, -5.3, -5, all the way up -6, -6.1, -6. We know it's going to hit all those, but we don't know for sure if it's going to hit -4. So there may not exist. Again, we can't tell for sure. If there actually does not exist, we just know that there might not exist or there might exist. We can't say for certain based on the theorem because that is not in that interval. And again, I did put these numbers in wrong just to show you what's going to happen here if you answer incorrectly. Well, we got an x, and I think it gives you a hint. Yeah. So here's the hint at the bottom. It says, remember when stating intervals, the smaller number must come first. Here was our solution, so we just swapped those like we said we were going to do, just to show you here. So let's go back. Oh, lost connection here. All right. I don't know how to actually do it again. I suppose you'll have that option. Some of the teacher mode, I don't think I do. You should have that one again. All right, you can go back and see this again. No, I don't know if I can do it again, but again, you'll have three chances on this. So if you flip an interval or something like that, you do have an opportunity to correct it. Again, I know that's a little bit confusing on which one goes into which one. Just take your time, do the best that you can for this. Just remember that the first interval are y values and then the x values, and figure it out from there. If you still are confused, make sure you do reach out to me and I'll help you get through it. All right, see ya.